Welcome to Ask and Learn.
All right, so this one has many parts. And so we're determining whether some of these expressions are linear, homogeneous, recurrence relations. So for A, we're given that an is equal to 3 an minus 1 plus 4 an minus 2 plus 5 an minus 3. So is it linear? The answer is yes, right? Because nothing is raised to a power. It's just a combination of previous terms only being multiplied by a constant, not being multiplied by anything else. So it is linear. Now, is it homogeneous? Well, in this case, it is. And that's because it does not contain any constant terms. There's no plus 7 at the end. Okay, and so now, since we know that, we can determine the degree. And the degree is the highest k for which an a to the n minus k occurs. And in this case, it's 3. So it goes sort of 3 units back. So k is equal to 3 for the degree. Okay, so for B, we're given that an is equal to 2 times an minus 1 plus an minus 2. So in this case, it is not linear. And this is due to this n being multiplied on the an minus 1 term. Next, the 2n is not a constant. It is, however, homogeneous. And that's because there are no constant terms, right? So there still isn't any sort of like plus 7 hanging up on the end. Okay, so now we will move on to the next one here, letter C. And in this case, an is equal to an minus 1 plus an minus 4. In this case, it is linear. And this is because each of the terms are only being multiplied by constants, in this case 1. There's nothing being squared. And it's also homogeneous, because again, there's no constant terms. Okay, so in this case, then the degree is going to be equal to 4. So that's the largest n minus k we see. It looks like I might be able to fit D right next door here. So here we're given n minus 1 plus 2. Okay, so in this case, it is linear. So none of the a terms, and I missed that it's equal to an, but none of these n minus 1 and minus 2 terms are being squared or multiplied by anything other than a constant, so it is linear. However, it is not homogeneous. And this is because we have the plus 2 term there. Okay, so for E, we get that an is equal to an minus 1 squared plus an minus 2. So here it is not linear, and this is due to being squared. Okay, but it is going to be homogeneous. And it's homogeneous because there is no constant terms. For f, we get that a of n is simply equal to an minus 2. Very boring. At some point, you're just going to get the string of the same numbers. But for this exercise, we can state that it is linear, right? Because there are nothing being squared, nothing is being multiplied by anything other than a constant, and it is also homogeneous. And this is because, again, there is no constant term. And so we can determine the degree is equal to 2. Okay, last one. So we're in G here, and in this instance, we have an minus 1. Notice we have an is equal to an minus 1 plus n. Okay, so in this case, this is not linear. Okay, so n is not a constant or a previous term. And it's also not homogeneous. Right, and it's not homogeneous because of this n again. So n is not a multiply of a term, any of the a, k, any terms in this sequence. So not linear and not homogeneous for the final letter.